Hello and welcome to the Galapagos Conservation Trust's inaugural webinar on what is World Nature Conservation Day. Thank you so much for giving us your time to hear more about the plastic pollution-free Galapagos. My name is Andy Donnelly. I've been working on this program, helping develop it now for about 3 years, but I'm delighted to be joined by two of the other leaders of the program, oceanographer and climate scientist Erik van Sebille of the University of Utrecht and marine biologist of GCT and Exeter University, Jen Jones. Erik, Jen, are you there? Just give us a quick unmute and say hello.
Hi Andy. Very happy to be here. Very excited.
Great.
Yeah,
Jen,
hi,
are you there?
Andy. I'm here,
hey.
yeah.
Before we move on, I must say congratulations to Erik, who has very recently won a really prestigious award from the European Research Council in the public engagement in research. Congrats, Erik.
Thank you.
That's good news for everybody listening, but it does set a bit of a high science communication bar for me and Jen, but we will do our best. What's going to happen is I will give an overview of the program at an introductory level, and then Jen and Erik will go into more detail on the aspects that they're leading. It would be good if any questions, you could post them on the chat, and I think they are on the instructions that were sent with the invite. You'll see that at the bottom of your Zoom. We'll get to those in a Q&A at the end, and any that we don't get to, we will put together in an FAQ sheet, which we will circulate. Just to note, we are recording, and if you don't want your name to appear in that chat, just change your Zoom settings. Okay, I'll get going. So, plastic pollution-free Galapagos, the story so far. Well, I'm going to start the story at the end. This is where we're heading. This is the vision. We want a Galapagos marine reserve which is free from the threat of marine plastics, that provides the world with an example of how to tackle this global problem, a regional scale model of hope for all protected areas. And there is growing hope, I would say, within the program that this is now a realistic vision. And I would hope that over the course of the next 35, 40 minutes, we can share that with you. So back to the start. It started way before the incredible rise in public perception around this issue. This is a picture from back in 2017, when the national park had, for some years, it has to be said, become increasingly concerned about the influx of plastic pollution to the archipelago. The image that you see on the left is pristine Galapagos. That's how you would like to find it. Beautiful beaches, lots of biodiversity. The image on the right, not what you would expect to see, heavily polluted with marine plastics. And at the time, the park really didn't know where this was coming from or what to do about it. And it's a big problem from two perspectives, I suppose, from the park. Really, how do you protect the biodiversity? Because of course the animals don't discriminate between how they use these two shorelines. And two, brand Galapagos. I mean, Galapagos is the place that is possibly the most revered, protected, highest levels of protection of any reserve anywhere in the world. So if this is the situation, something needed to happen. So what? Well, there are some really good examples around the world of places that have managed to clean up. They've done it by identifying the sources of pollution, and then through strict enforcement of policy and really good education campaigns, managed to shut down those sources while intensively clearing up. This is actually an image from a river in Indonesia, which took about 2 years to get from what you see behind the picture, in the front of the picture, to behind it. And the examples that are like this around the world are all from freshwater systems. There hasn't been anywhere an archipelago, a coastline that has managed to achieve this. So how do we take those learnings from the freshwater system and apply them in a marine system? Of course, it's much easier to manage in a freshwater system at a catchment level than it is to an ocean basin level. And these are the problems that we posed. The global experts in this field, and we put them together with the Galapagos science community, the Galapagos community, and the authorities. And over the course of a series of pretty intensive workshops, they came up with a plan. And that's why this group of people are looking particularly pleased. They have worked through the problems and come up with this 4-year plan to get to the vision. And it hinges around understanding what the knowledge gaps and the capacity gaps are in those 3 systems that you see there. They're all part integrated into this problem: the physical system, the biological, and the human system. And you can break down those questions that underlie that into summary like this, really. In the physical system, what are the sources? Where is the pollution from? What happens to it when it gets to the archipelago? And what damage does it cause? What is the impact? And how do you focus mitigation efforts on stopping it harming the biodiversity? And by answering those 2 questions, sets of questions, they drive the 3rd, which is probably the most important. What do we do about it? What policy instruments are there? What education campaigns do we need? And very importantly, targeting which audiences. And we've run a series of pilot projects in each of these, under each of these themes. I'm just going to share some of them with you now. This is the cleanup and survey effort that has been happening every year since we started the project now, run by the National Park and partners, Conservation International and volunteers. We move from just a cleanup to survey. So 8 tons each year collected from remote Galapagos beaches. But importantly, now that's starting to be analysed and to look at what we can learn from the items that we're retrieving from the beach. Because taking almost an archaeological approach, each item in itself has a story. And it's important that we understand those stories if we're going to get to the root of the problem. And even a fairly coarse level, just by looking at the origin of brands, it starts to break the problem down, and we start to get an insight into where these items are from. Now, unsurprisingly, Peru and Ecuador were dominant, but surprisingly China and many other nationalities as well. But it's only when we overlay this information with Erik's models, the oceanography knowledge, and a more intense survey, the type that Jen's been doing, that we really start to get a handle on what's happening here. We're getting there. As an overview, this is from some of Jen's data. We now know that really there's only a small proportion of this rubbish which is being originated in Galapagos locally. A much bigger proportion comes from fisheries that are operating in the nearby water, and some of those have been in the news recently. We can touch on that a bit later. And the large proportion is coming from the mainland. But importantly, and from Erik's work, we know that it's actually probably only a relatively small area. So this helps us target these communities. So understanding and answering these questions is key. But what happens when the rubbish gets to Galapagos? What impact does it have? I hand over to Jen now. She's been leading this area. Jen, if I stop sharing, can you take over? Let me see.
Okay.
Have you got
Give me a second.
No worries. Then I'll mute.
Okay, hopefully that's
Are you good?
Hi everyone. My name's Jen. I have been working with GCT since 2011, and in the last couple of years I've started a PhD with the University of Exeter, looking more deeply at this problem of plastics in the islands. So when we're thinking about impacts of plastic pollution, there's 2 major areas that Andy's already touched on: the socioeconomic impacts. So this is looking at how plastic pollution impacts the 2 main industries of the islands, basically. So estimated 80% of the local economy is tourism. This image you can see on the left is a popular visitor snorkeling site on one of the remote islands, which is very much not what your mental image of idyllic snorkeling in Galapagos would be. And yeah, that possible impacts on the brand of Galapagos is of real concern for the whole society. The other area of socioeconomic impacts is fisheries. And so plastic pollution actually can be very dangerous to maritime activities. For instance, discarded fishing litter, getting stuck in propellers, things like that. Also, the biological impacts of plastics entering the food web and affecting commercial species. That links into the other area of impacts, which is where my research is focused on, to try and understand more about the biological and ecological impacts of different types of plastic pollution and how they interact with other pollutants and stresses in the food web. So I work very closely with Juan Pablo Munoz, who's based in the Galapagos Science Center, and many other researchers in mainland Ecuador as well. And together we're trying to get an accurate picture of just what the impacts of plastics are in Galapagos now and what they might look like in the future under different scenarios. So how do we go about starting this research? There's many species that we could be focusing on. We've developed a risk assessment methodology. So for over 3,000 species in the Galapagos marine food web, we've analysed them for their distribution. So how endemic are the species in question? Some are endemic to the archipelago, meaning they're found nowhere else in the world. Some are even endemic to a single island or a single bay. And so the impacts on those species are going to be a priority for us. We then looked at the IUCN Red List to understand more about the conservation status of these different species. This is much easier for very iconic, easy to study species like sea lions or penguins or albatross. Not many invertebrates and fish species have been analysed for the Red List, and so that makes it a challenge to prioritise the research for those groups. Then after that, we looked into the scientific literature for evidence from other places and studies on other species that would likely have similar risks, because right now we don't have any information in Galapagos before we started this work. So we use proxy species like these examples, which have been well studied. These are both found in Chile, the Magellan penguin and the South American fur seal. A lot of research has gone into how often these species interact with fisheries litter, how often they eat it, what those impacts might be. And we can assume that the risks would be similar for Galapagos species as well. So from this analysis, we've identified some first priority species. We're preparing this data at the moment for publication, but some of the highlights to share with you. Unsurprisingly, the Galapagos sea lion scores very highly. They're very playful, interactive creatures. A lot of the photos that we've seen so far are sea lions that have been entangled in plastic. The waved albatross scores very highly. We know all around the world that albatross are very negatively affected by plastics. They feed on floating plastics in the ocean. We know that the waved albatross forages close to the continent in the Humboldt Current. And we're also concerned about the intergenerational risks of seabirds, so where they feed at sea and then bring it back to their offspring. Corals are a big concern. There's not many in Galapagos, but we know that plastics increase disease risk of corals as well as bleaching events. Sharks are more and more endangered, that we've also seen a lot of coverage of recently, more and more reports of interactions with plastics. The lava gull is the world's rarest seagull. We recorded them at all of our most polluted sites. They're very curious birds as well, so they're encountering a lot of plastics. And the marine iguana is kind of hard because there is no other species around the world that can work as a proxy for this. The only seagoing lizard in the world, we're assuming at the moment it might be kind of similar risk to a turtle, but we've started a study just focusing on this species because we really don't know what the risks might be. So what are the next steps in this research? Well, we want to establish what's going on in the priority habitats of these species. So we've started citizen science surveys, working with the national park rangers to collect more data in the most important habitats. We want to understand the encounter rates, so how often are species interacting with plastics, and how severe are those encounters. It is, of course, also a terrestrial problem. This image on the left is quite disturbing of a yellow warbler that has used a lot of plastic in its nest and is thought to have been entangled in that too. So we will be looking at the terrestrial ecosystem in the future as well. And then we want to understand, put all this information together, as well as with researchers looking at other stresses, so other pollutants, looking at illegal fishing and poaching, climate change, impacts like that, invasive species, to understand how much stress the ecosystem is under as a whole, and where we can have the best or the most effective impact in tackling these challenges. Okay, so now we're going to hear a little more about the physical system. So I'll hand over to Erik. Let me just stop sharing my screen one moment.
Yeah, thank you,
Jen.
And let me then start sharing my screen for the third in this marathon of very short sprints of presentations about the project. So I am Erik van Sebille. I call myself an oceanographer, and I'm a climate scientist. And I particularly investigate how ocean currents move plastic around. So essentially, to play the blame game of whose plastic ends up where. And to put the Galapagos a bit in perspective, I think it would be good to first zoom out and try and have a look at what the global situation of plastic at the surface of our ocean is right now. Back in 2015, I led a large study with international groups around the world to try and come up with what at that time we thought was and still think, is the best map of the amount of plastic floating on the surface of the ocean. For that we used nets, manta trawls that were trawled through the ocean in all ocean basins, and we combined that with numerical simulations that I will shortly talk about to come up with this. Now what you see here in gray are the continents. I mean, as an oceanographer, I don't really care about land, so I typically make it gray. The real action, of course, happens in the ocean. And the coloring here is the amount of plastic floating at the surface of the ocean right now, going from blue, being very low amounts of plastic, all the way to dark red here, which is almost 100 million pieces of plastic per square kilometer. Now, what immediately stands out in a map like this is that there's areas where there's much more plastic floating on the surface of the ocean than others. Particularly here, this is the infamous garbage patch between Hawaii and California. What you sometimes hear, the area twice the size of Texas, the plastic soup if you want. But there's also very high concentrations in the Atlantic Ocean, both in the north and the south. There's very high concentrations here around Southeast Asia. And there's very high concentrations here in the Mediterranean. Now, the flip side of that is that fortunately, we still live in a world where there's also areas with low concentrations of plastic floating on the surface of our ocean. In particular, here around Antarctica, where the ocean is still pretty pristine and there's not that much plastic yet. There's also here Baffin Bay in Canada with very low concentrations. And most relevant, I guess, for what we are here for today, along the equator. Now, the way that the ocean circulation works is that along the equator, water comes up from the deep sea. So the water comes up from below with with hardly any plastic, because most plastic is floating on the surface of the ocean. And as it comes up, it flows away from the equator. So in net, there's a little bit of flow away from the equator, and that explains why this blue band is right here. It's just a peculiarity of how the ocean currents work and how they interact with the rotation of the Earth, essentially, that gives you this band here. So that means that the Galapagos, right here in the Pacific Ocean, is in a somewhat unique place. of all the ecosystems that are under pressure from human activities in the world, the Galapagos is in the only place where there is relatively low amounts of plastic still. And yet, we do find plastic. As Andy showed in his photos, as Jan has detailed in her work. Well, as you can see in the background of the picture that I'm here now is a bay in Galapagos. There is plastic. So the question is then, well, where does this plastic really come from? And to investigate that a little bit further, we did some simulations last year. And in particular, I show here 2 computer simulations. This is the kind of research that I very typically do. So we use computers to track essentially virtual pieces of plastic. It's as if I'm virtually polluting the ocean without doing any harm, of course, to the animals that live in there. Now, this simulation here on the top left shows virtual pieces of plastic from anywhere in Southeast Asia. And see that they move into the Pacific Ocean, and many of them indeed accumulate over time in the timescales of years in this garbage patch between Hawaii and California. Some of them move into the Indian Ocean. Importantly, none of them come even near the Galapagos, this red area right here. There really is no way that plastic can directly travel by currents from Southeast Asia to the Galapagos. That is a near impossibility, I would say, scientifically speaking. On the other hand is the simulation here on the bottom right, where you see all the plastic that starts on the coastlines of South and North and Central America. Here you see that the blue particles, the ones that don't end up near the Galapagos, are still there. And now the simulation is starting all over again. So let me just... but you also see some red particles. The red particles are the particles that do actually cross through the Galapagos archipelago in this case. And you see that most of them actually come from Peru and from Ecuador. So the question is then, how does plastic that end up near the Galapagos that has a lot of Chinese imprint, for instance, as Andy also said, how does it even get there? It can't be directly from the ocean currents. Another possibility would be the fisheries. So we also did an analysis where we looked from all the known fisheries grounds, and this is from AIS data, so essentially the shipping vessels identification systems. We looked at where typically fishing is occurring in the area around the Galapagos. So here's the Galapagos again, here's Ecuador, Peru, and you see that there's a lot of fishing occurring all the time around the Galapagos. And from some of these locations, there's actually a very, very high probability that plastic ends up near the Galapagos. So it can very well be that plastic, especially when the fishing is happening on the eastern side of the coast here of Peru, the plastic can end up there. So we now have a bit of an understanding of how plastic can enter this region here. But really, of course, what we want to know is what happens when it is there, when it does move into that system. And that is what in this second phase of the research that we're doing right now. Now, this is very preliminary data that Stephanie Ipma, who works in my team, put together for us. And this is not a toddler just scrabbling some lines on the map of the Galapagos. These are all virtual pieces of plastic that have been simulated in a much, much finer resolution model of just the Galapagos archipelago. And in this case, we've particularly looked at all the virtual particles that end up near San Cristobal Island, right here. Now, the key thing that we want to do in our model is to do this for, or in our work, is to do this for all the different islands and understand how plastic moves between the islands and how it moves between the different beaches on the islands, so that we can best figure out how the plastic moves around and where it does most harm. We do that with simulations, with computer models like this, but we will also use drifters, observations to ground truth the models. They look like this. Here's one in my hand right now. It's a it's a prototype still. We're developing this together with the company that makes these. And the idea is to deploy those drifters in the Galapagos archipelago at very carefully identified locations so that we can best map how plastic ends up on each of the different beaches around the Galapagos. Now we want to do that. We want to target beaches because then we can come up with maps like this. This is an example map where we show what the probability is of beaching in each of those maps. And of course, maps like these could be extremely useful to park rangers or to others in the archipelago who want to go out there and clean up the beach. Our goal is to somewhat make a predictive tool, call it a weather forecast, but then not for the actual weather, but for the plastics in the ocean, and help the rangers plan their cleanups of beaches. Because the key thing, and I think one of the most important scientific insights that underpins this research, is that we are not per se interested in the most polluted beach. The most polluted beach, the one with the most plastic out there, it could just be a result of years and years of a very, very slow washing up of plastic on that beach. Say in this situation, there's a lot of plastic on the beach, a little bit of plastic in the sea. Plastic in the ocean does much more harm than plastic on the beach. So if you clean up the plastic here, well, yeah, sure, then you've got a clean beach, but it doesn't do anything to the amount of plastic in the ocean. Instead, what we look at are beaches that are a bit more like this. They're much more dynamic, there's much more waves, there's much more action going on, and what happens then is that plastic keeps going back and forth between the ocean and the beach. If you now clean up the plastic, then ta-da, you've also cleaned up the ocean. So really what we want to target is to take out the large pieces of plastic before they can be pushed back into the ocean, because they can wash back into the ocean. Because if we do that, and especially in a dynamic region like this, where there's a lot of scrubbing going on, by taking out the large pieces of plastic, we actually prevent a lot of microplastic occurring. Because single large pieces of bottles, at some point, they just break down. They break down in the ocean like this, but they also break down on beaches. So we want the beaches where the plastic is constantly going back and forth. Now that then will end literally in an app. What we are going to produce in this project is an app where park rangers or others who want to do cleanups, they can predict, they can look where they have the highest probability of finding plastic, that if they take that out, they will actually remove the plastic from the ocean too. And then the Galapagos is just the beginning. As Andy said, the Galapagos in this project is really the exemplar, the showcase that shows that we can do this. But the technology can then hopefully be applied to many, many other areas around the world. Indonesia, Tasmania, Svalbard, which is really interesting because that's where most of our European plastic ends up. Our UK plastic, Dutch plastic gets carried by the currents past Norway and ends up in the Arctic. Hawaii, Greece, and maybe even the Wadden Islands that are so dear to me because it's right next to where I live. And then in the end, with this tool, hopefully we can really make a dent in the amount of plastic, not only on our beaches, but also in our oceans. And by that, really prevent harm of all this horrible material. Thank you.
Thanks, Erik. It's really exciting. I'll keep you in driving if that's all right, Erik. There's oh no, go back.
Sorry.
That's okay. In fact, I'll share screen. We've just got a summary slide there. Okay, so I'll just take over the baton.
Yeah.
Yeah. Okay, hold your horses. Just bear with us. Hold on a sec. Where are we? Okay. Yeah, thanks, Erik. I'll just wrap up before we go to the Q&A there. So where we're up to is we know that marine plastic pollution is a is a serious threat, particularly in Galapagos. But the difference is that we now know what to do about this. We're starting to understand how we tackle it in Galapagos. There's a good 4-year plan that's in place. There's a roadmap, if you like, where we're filling knowledge gaps, capacity gaps. We're developing these tools that Erik has pointed to. We're starting to understand the infrastructure needs on the island and within the region. Certainly over the course of the next 4 years, we will do that. And we can use all of that to drive behaviour change. It's going to cost about £4.5 million, and we've secured about 3.5 of that to date. And I think there is growing hope, certainly within the scientific community that are working on this project, and definitely within the Galapagonian community, that Galapagos is well placed now to become that example of how a marine reserve can tackle this problem. And the picture that you're seeing there is really a reminder that part of that hope, in fact, most of that hope really is coming from the community themselves. This is not about scientists working out what to do by themselves. This is being driven by the Galapagonians. There are examples, entrepreneurial examples. There are educational activities. It's wonderful to see what the children are doing. It's coming in from a high level, from a policy level as well. And it is really throughout the whole Galapagos community. This is just one example you're seeing here. I might let Jen pick this story up. Jen, do you want to explain what's going on in this picture here?
Yeah, thank you. So Kimberly here is a member of the Gecko Youth Club, which is in San Cristobal Island. They're a group of young people between 12 and 15 years old who are really motivated to make a change in their community and to share the messages wider as well with the mainland. And what she's doing here is making a bottle cap doll. So when they do beach cleans, they've been collecting bottle caps, and they've made hundreds of these now. And the main reason for them is as a gift to the taxi drivers. And they've given one to every taxi driver on the island to hang up on their mirror to remind their passengers to bring their reusable bags next time they go shopping. So this is a completely generated idea from the youth group. They designed posters. They designed a how to do this for the school kids, and have done sessions at the schools as well. So I just think this is a really inspiring case study of how there's so many good ideas and innovative, creative ideas to tackle this issue that are coming from the community, as well as the top-down policy stuff that Andy said as well. So yeah, I think these kind of give us hope that there is a positive outlook in places like this to be able to learn from and make some change.
Thanks, Jen. Yeah, and I can just show you one here. So this works not just in Galapagos in taxis. So this was a present from the group to me. And this guy, we call him Juan Pablo, after JP that Jen mentioned. He hangs on our front door to remind us to take our bags when we go shopping. So it does work. So thank you very much for listening. We'll go to the more interactive part of the session. Now, I think I'm going to have to stop screen sharing to get my chat up. While I do that, would somebody share theirs and leave it on that screen for me, please? I'm just going to stop. Okay, I can see the chat now. Are we good? Okay, got a load of questions that have come in here. We only have 10 minutes or so, so I'll just pick some that pick on a theme. Well, the first one that came in: what happens to the plastic once it's been collected from the beaches? Can it be recycled, or does it have to be shipped off? I'll hand that to Jen and then back you up if you like.
Sure. So this is going to be a big research focus for us over the next few years of how we can add value to the plastics that we're cleaning up. So we're working with some circular economy specialists to look at what kind of life basically we can give this waste plastic, because right now we do have a big issue Landfill is very finite in Galapagos, and we're already having a lot of issues, particularly in Santa Cruz Islands with that. There's a limited amount of recycling that happens on the island itself, but most of it does need to be shipped back to the continent. And so we are looking for kind of in situ uses of plastics, which is, going to be a research focus going forwards. We've got some small scale things that are happening, again, community groups who are grinding plastics and then melting them into souvenirs for tourists, which are really effective to, again, raise awareness. But obviously this can't be done on the scale of 8 tons a year. So solutions for this are a real priority for us to find.
Yeah, thanks, Jen. I think you answered that pretty comprehensively. I'll move on given time. And a really important question from Helen here. Have the fishermen engaged in this work? Are they aware that they could be helping reduce this pollution? The answer to that is yes, at a number of different levels. So there are different fishing communities here. There are the Galapagonian fishing community who have license, and at the moment, at least, it's all just hand line. It's very artisanal level. Then there is the Ecuadorian waters that surround, and then is Ecuadorian bigger scale fisheries, but managed by Ecuador. And then there's what happens in the international waters. And we're engaging with each of those levels, but particularly to start with Peru and with Ecuador. And the wider program, the partners include the fisheries departments from there, and they are aware about this. The international fleet outside of those countries, I think it's going to take a little bit more, and the program will build a pretty compelling body of evidence that we hope will support policy change. So that will be coming. Erik, do you want to pick that up on any of the sort of international aspects?
Yeah, exactly. So so one of the things that we're also exploring right now is whether we can work in liability law, and whether the things that we find on the beaches in Galapagos, whether through international law we can hold somebody responsible or liable for that plastic. That is partly the fishing gear. If we know which industry, which type of fleet is using that gear, then can we somehow take the fleet accountable. But also, for example, the bottle caps. So we're exploring whether this is possible under international law to make or to help the producers of the bottle caps, to help them liable for the bottle caps that are found on the beaches in the Galapagos. And that hopefully is another avenue to really make this problem disappear as quickly as possible.
Thanks, Erik. We'll keep you while you're on a roll, and this is a good test of your science communication skills, this one. Can you answer this one succinctly? A technical one about the difference between micro and macro plastic and how it behaves in ocean currents. Off you go.
Yeah, well, so in this project we focus on macro plastic, because macro plastic, the larger piece of plastic, is what you can actually take up from a beach and what you can remove. Once the plastic becomes micro, it is so small, and it is also so intertwined with the life. Algae start to grow on it. You can't take it out of the ocean anymore. It is too difficult to separate it from fish larvae, from all the other things that are floating around. So that is why particularly we focus on macro. But don't forget, macro plastic, the large plastic, becomes microplastic, especially on the type of rocky, sandy coastlines that we see in the Galapagos.
Thanks, Erik. One about how we share this work more, which is going to be a really important feature. Other ways from Helen, again, the other university students and other interested in this work to track your progress. Well, yeah, the comm side of things we're going to be upping. We've been in development mode so far, really, and from January we will be in a position where we are better resourced and we have more formal communication lines. I know that Erik and Jen both share within their universities, and this is part of a network. You know, those 22 organizations all have their own outlets, and we will be channeling the information through them. Erik, Jen, do you want to add any more on that?
Just to mention it, in Galapagos itself, I work with a lot of university students to actually collect this data, which is really, really great that they are experiencing parts of their islands they wouldn't get to visit otherwise. We trained them when we were out there, and they've continued to be able to go back, particularly to one very interesting beach for us every month for, well, almost a year until the COVID closures, which gives us a really unique insight into that accumulation rate as well. So then we are going to help to train them in the analysis of that data and really get them involved in the whole process, which is really positive as well.
Yeah, and we just had a meeting just before this around the citizen science portal that we hope to develop on the back of it. You know, there's going to be not just opportunities to find out what's going on, but actually to take part. So, you know, this work lends itself really well for remote engagement. So just keep your eye out for that one, and hopefully we'll be able to meet a mass audience with that.
Well, and don't forget about these, right?
Yeah, go ahead.
Another way of engagement. It's citizen science in some way too. So these, so the drifters are now being developed and built, and then hopefully in spring we will deploy them. And the idea is that we also have some as an adopt a drifter program. So they're roughly $700 a piece or so, but we hope to get people to adopt one and then live track them in the ocean. So they have a GPS and a satellite communication device, so we can live follow them, and you could follow your own drifter in some way through the ocean.
Great. Back to Galapagos. Are eco bricks made in the area? I don't know if they are. Jen, do you know about this? Are there?
I'm not sure. I know exactly the people to ask, but no, I don't know if they've been tried yet. So we should have a look at that for sure.
Yeah, and I think some of these alternatives will come out through the course of the program. You know, once we start to be able to engage really deeply within the community on that, and what are the economic components for or aspects of this that we'll be able to help understand and then drive as well. One on funding, the economics. So where do we find the $3.5 million from? Well, we've been seed funded really generously by the Evolution Education Trust, which is a private trust in Cambridge. And a lot of the funding then has come from partners, and we've been part of a big grant application, which has been secured. We will need to find that other million, but we're hopeful over the course of the 4 years that we have some pipeline for that. I think to finish on, we're okay. Just got a couple of minutes. This one leads us nicely, I think, to where this might go, because the question around which countries in Europe are the biggest contributors to pollution in the Med. I think Erik might have an insight into that, but my take would be, if we don't now, with the kind of tools that we're developing, we certainly will be able to. Erik?
Yeah, absolutely. So we're now exploring also what is happening in the Med, where the plastic in the Med comes from. It's probably not so much Europe these days anymore as it is more on the African side. But exactly with these kind of technologies, with the drifters, with the predictive tools, the app, if you want, we would be able to get much closer to where we can really target and also clean up places like the Mediterranean.
Thanks. Jen, do you want to add any more before we close up? I'm aware of time. We've got one last question on Lego. I'll just jump in there. Not at the moment, but we are talking to a number of potential corporates who might be able to get involved and help us, including them. They'd be great. Jen, do you want to add any more before we close up?
Nothing specific. Just thanks for coming along, everybody. I personally am really honoured to be part of such a exciting program that truly international. We really value the capacity building and ensuring that what we're developing in the islands can be exported to other places that are perhaps even more vulnerable. And yeah, just a big thank you for all of your interest, and I hope that you stay with us on the journey as it develops.
Yep, thanks very much. We'll wrap it up there. As Jen says, thank you for joining us. Really appreciate your time, and please do keep in touch with the program, and we'll do our best to feed the information to you. Thank you.